Welcome, my friends. In this video, I'll be going through Google Sheets lab number 5. Now, typically I would say if you'd like to follow along with the file here, you can go ahead and download that, but as you'll see here, the tabs are pretty blank besides this hypergeometric tab, and we're not really going to do this in this video, so maybe you don't necessarily need to download the file, but I will put this file in the description. If you'd like to download the file and be able to edit it, you can go to File, Make a Copy, and then you can save that as your first and last name or whatever you'd like. Google Sheets lab number 5. Make a copy of that, and then you should be able to edit this file. Now, in this very first tab here, we're going to create a model that will basically calculate probabilities on a binomial distribution for us. So if you're unfamiliar, a binomial distribution is a distribution that can be used when 4 different conditions are met. So let me just show you or remind you of those right here. So there must be a fixed number of trials, kind of like a sample size, and on every one of those trials you should have 2 possible outcomes, either a success or failure. The chance of having a success on each trial should be the same on each trial, and it's represented by p, and each trial should be independent of the others. And the most common case of a binomial distribution, or usually the way that it's kind of introduced, is for flipping a coin a set number of times. So those fixed number of trials, if you're flipping a coin, maybe you're going to flip the coin 10 times, and that would be your fixed number of trials, your value for n. And maybe the 2 different outcomes, well, you could have either heads or tails when you flip a coin. So maybe heads is success or tails is failure, or you could flip those around if you'd like to. The probability of success is the same on each trial. There's a 50-50 chance of flipping heads on each flip of the coin. And then the outcome of any one flip of the coin is independent of any of the others. So it doesn't matter if I flip heads on the first flip, that's not really going to impact any of the other flips. So this would be a case where you could use the binomial distribution in order to model probabilities. So a type of question you could answer using the binomial distribution would be, what's the probability that if I'm going to flip the coin 10 times, that 3 out of those 10 times it lands heads face up. So we're going to create a model that will do that for us, as well as create a binomial histogram. So let's go back into our file here. So the way I'm going to start this off is I am going to create some labels here. So I'm going to have x and p of x. I'm also going to do the probability of x being less than or equal to x. So that's going to be like a cumulative probability. We'll talk about that a little bit later. And then I want to have a couple of cells over here. We'll have n, and then we'll have p. Let me kind of just adjust the size of some of these. Maybe we'll adjust the size of a couple of these columns here a little bit. Maybe the x doesn't have to be so big. And then for the n, we'll kind of start off with modeling this this coin flipping example, but we'll make this work for other examples. So we'll put in 10 for flipping 10 coins, and we'll put in 0.5 for the chance of flipping heads on each flip. Okay, so then what we're going to want to do here is we're going to want to populate this very first column. This column is going to represent x, which is the number of heads that we end up flipping. And if we're going to have 10 coins flipped, we could have anywhere from 0 all the way up to 10 heads flipped. But I want to make this model flexible so that it will work for if I change this n to 15 or to 5 or anything, that this column will also change with that. So we're gonna learn how to basically model this first column so that it's going to generate the number of values associated with n. Now I'm only gonna do this up until about 15. Typically binomial distribution isn't used too often for numbers that are too large for n, but we could model this for as big as we wanted, but I'm going to model this for up to 15. So the very first cell here, I'm going to put 0. I'm always going to have the possibility of basically 0 successes. I'm always going to have the chance that no matter how many coins I'm flipping, there's always a chance that I don't have any heads flipped, right? So I'm always going to have this possibility. So I'm just going to hard code that in here. I'm just going to type in 0. Now, probably there's going to be the chance of having 1 as well, so I could just type in the 1 here, but I'm going to use this opportunity to start the coding here. So I could do the 1 here and then really start the coding in the next row, but I'm just going to do it right here. So basically, I only want to generate a number in this third row if this previous number was less than n. So if this previous number was less than n, that means I need to generate another number. So let's say this number, we're further down, and maybe this number is 9, because this is going to have to work in general for any of these values. Like if the previous value was 9 and the value over here was 10, that means, oh, I'm not done. I need to generate one more. So if this number was 9, I want to generate one more number, a 10 right there, right? So the general logic would be check the previous number, and if that number is less than 10, or whatever this number is, then I should be generating a number here. And the way we're going to do that is with an if function. So I'm going to start with if. And so I want to check to see if this number, the previous number, is less than my value for n. Now I'm always going to want to reference this this value here, so I'm going to make that an absolute reference by pressing F4, because when I drag this down, I always want to be referencing that n equals 10. And if that is true, if the previous value is less than that number right there, then I want to generate another number, a number that is one larger than this number. So I'm going to take that number and I'm going to add 1. And then I'm going to do comma, so now I'm on value if false. So value if false, that would be if this number is not less than 10. Well, if that number is not less than 10, then it actually must be 10, or it must be that number that's right there. And I don't want to generate any more numbers. So I'm actually going to put in like blank double quotes here, just to represent kind of like a blank value here, meaning that we're just going to output nothing, or a blank string, if this number is not less than 10. So I'm going to close the parentheses here, and you'll see how this works. So I'm going to get 1 there, and I can go ahead and I can drag this down. I'm going to drag it all the way down. I can drag it down as far as I want, but I'm just going to go down through 17. And you're going to see here that it's generating numbers from 0 all the way up to whatever that value for n is, right? And if I was to change n to 11, then it's going to generate another number. Or if I change it down to 7, right? So this is generating the numbers from 0 all the way up to whatever n is. And I've generated or made this work for all the way up to 15. If I do something higher than 15 right now, it's not going to work. I could just, continue to drag down and it would work, but I'm going to keep this at working for just 15. So we're going to change this back. I'm going to change this back to 10. All right, so that's the first part of our model, kind of generating the value for x based on the value for n. Now in the next column here, we're going to generate the probability, and we can do that using a function called binom.dist. So I'm going to type in equal to binom.dist, and we can see the inputs here. First, we need the number of successes, which is the number in this previous column. So I'm going to click on that value. So this is trying to find the probability that x equals 0 here. The number of trials is going to be our value for n, so I'm going to click on n. I want that to be an absolute reference, so I'm going to press the F4. I always want to reference that 10 for all of the rows here. The probability of success is 0.5, so I'm going to click that and use F4 on that as well. And then I'm going to choose false for cumulative. Cumulative would mean I want the less than or equal to probability, but I don't. I just want the equal to probability, so I'm going to say false for that. I'm going to close the parentheses. I'm going to press enter, and there you go. It's going to give me that probability of a very low probability, 0.000976, etc. Right? So this is saying if you were to flip a coin 10 times, what's the chance that you don't get any heads? You get 0 heads, and it turns out that number is very, very small, right? And I could drag this down to find all the other answers here, and that would work. But the problem is this is not going to modify if I was to change this n to be a higher number or a lower number, right? It's actually going to give me some numbers that I don't really want here, especially if my n is lower. So I don't really want this this function the way it is. The first one is fine the way it is, but we need to modify this basically in a similar way that we did column A. Basically, we only want this to show a value if there is a corresponding value in column A. So if column A is a blank, right, like right down here, then we don't want it to show a value. But right now, if I was to drag it down, it is going to show a value even if they are blanks. So the way that we can do that is by using another if function, kind of similar to the way we did it here, right? So we're going to do another if function on the beginning here. And what we're going to check is whether or not the value right next to it, whether or not the value in column A is a blank cell. And if that value is a blank cell, which we're going to represent by the double quotes here, if that is a blank cell, then we don't want to return anything. If that value is blank, then this should also be blank. So we're going to do double quotes here as well. So this is saying if the number right next to it is blank, then I also want this cell to be blank. And then if I do a comma, if it's not blank, this is the value of false. So if the value right next to it is not blank, then I want to do the function. And so the value of false here is going to be the entire function that we just wrote. So I'll need to close one more parentheses here. You can see that matches up with the opening parentheses there. And press enter. We're going to get the same value as we did before in this very first value for the very first row here. But if I drag this down all the way through 17, you'll see that the later ones are not going to generate anything, right? And now this is going to be flexible so that I can change this n to anything from 0 to 15, and that's going to modify that column B. So pretty cool there. I'm going to change this back to 10. Next thing we want to do is calculate the less than or equal to probability. So this is what we call the cumulative probability. So this is saying, what's the probability that if I flip 10 coins that I get not 2 heads, but 2 or fewer heads, right? And there's a couple of different ways we could go about calculating this column. I can think of maybe at least 3 ways we could go about doing this. But the way I'm going to choose to teach this is to teach this using the sum function. So basically what we're going to want to do in this column here is we're going to want to sum up all the numbers in the previous column up to including that value. So for example, if I was in 4, if I want the probability of less than or equal to 4, I want to take 4 and all the ones above it and sum them together. Or if I was on 7, I want to take 7 and all the ones above it and sum them together, right? And the way I can do that is by using a sum function. And I'm going to sum this value, but I also want to sum all the values above it. Well, of course, for the very first cell, there is nothing above it. So the way we can do this is we want to make this B2 an absolute reference. And then if I type a colon here, so shift and then the colon, and then if I just do B2 again, and I think I have to type it out here. If I do B2 again, what this is saying is, I want my first reference here of B2 to be absolute, meaning it will not change, but I want this second reference to B2 to change. So therefore, when I drag this formula down, it will basically be an expanding range. So let me show you kind of how this works or what this will look like. So let me drag this down through the cells that we have. So the first one is just summing the first value. We're just basically grabbing that first value. The second one here is summing the top 2 values. The B2 stayed the same, but the second B2 changed to B3. Or all the way down here. Now it's summing. It's basically just summing up all the values up into including that value. Now once again, we're going to run into the same issue here that if I drag this past row 12, it's going to continue to give me numbers, but I don't want it to continue to give me numbers, so I'm going to have to do the exact same idea here with the if function. So I'm going to do the if here, and if this value is a blank cell, if, and then I'm going to do the double quotes, is equal to double quotes, then we also want to return a blank cell for this column. Otherwise, value if false. If it's not a blank cell, then we want to return this sum function. And now when I drag this all the way through 17, you will see that that does work there, and I can increase the value for n, and then that will modify that as well. Now, right now, I'm noticing it's kind of messy here with all the decimals. Maybe I don't want this many decimals, so I'm going to go ahead and I'm just going to decrease the decimal places on these to maybe 4 decimals, and that's going to look a little cleaner. Okay, we're almost done here. The last thing I want to do is create a histogram based on the first 2 columns. So I'm going to highlight the first 2 columns here. Actually, I'm going to change this to 15, not 165, 15. And I'm going to highlight the first 2 columns all the way down through row 17. I'm going to go ahead and insert let's see here, a chart. And I'm going to change that chart. If you change it to a histogram, it's going to not actually treat it the way that I want to. You can see here that's not really the type of histogram that I want. It's kind of plotting the probabilities there on the horizontal axis, which is not what I want. So I'm actually, to get a histogram proper for this, I'm going to have to choose the column chart right here. And there you go. I will have my, my histogram. Now let me go ahead and modify this a little bit. Let's move this a little bit to the right so it's kind of over here. Maybe I'll shrink it down a little bit. I'm going to change the title. I can either change the title over here, or I think I just double click on the title and I can title this binomial histogram. Maybe I want to center that. And then my horizontal axis, I'm going to change this to the number of successes. You might think maybe we should put this to number of heads, but I'm doing this in general. Maybe this isn't necessarily related to heads. I'm noticing now that some of these values did not get rounded, so let me get those as well. So I'm going to put that as number of successes, and I'm okay with p of x here. I guess you could change that to probability or something like that, but here we go. We have our histogram. We can see that it is a normal histogram. Now, if I was to change n, you can see here it's also going to change the histogram, or if I was to change p, you can see that we're going to start to get some sort of skewed distribution. Okay, so I think that is just about all I wanted to do for this. Maybe just cleaning up a little bit more. Maybe I will just add some borders around some of these to make it a little bit nicer. Maybe I'll center the numbers, so I can go ahead and center some of these values here. Center some of the values. Maybe I'll bold some of the values here, so I'm doing Control B to bold those, or you can click on the B over here. And maybe I'm going to put these are kind of like input cells, so maybe I'll change the color of those to some sort of green, so the user knows, oh, I can change those numbers, and that's going to modify it. And once again, I should probably make this table work all the way through these. There we go. So now you're going to see, yeah, so this does look fine, and it is modifying the way that I would hope it to. All right, so there you go. That is our binomial histogram. And that completes the binomial portion of this Google Sheets lab. Next, let's go to the Petersburg tab, and this relates to the St. Petersburg paradox. And if you're not familiar with the St. Petersburg paradox, let me show you what that's all about. So the St. Petersburg paradox relates to a game where you're going to continue to basically flip a coin over and over and over again until you get the first success, which would be a heads flipped face up, right? And depending on which flip has the first heads, you will win a differing amount of money. And this table kind of explains it well here. If you flip a coin in the very first flip, you flip heads face up, then you're going to win $1. If you flip the first heads on the second flip, meaning you actually got a tails and then a heads, then you would get $2. If the first heads was on the third flip, that must meant that you did 2 tails and then a heads, and then that would be $4. And you can see the numbers start to double and double and double, and these numbers can get really, really large, really, really quick. But the chance of getting your first heads on a later and later trial gets less and less frequent, or less and less likely. And the reason why this is a paradox is because the expected winnings actually end up being infinite here. So you may know that to find the expected value of a discrete distribution like this, you can simply take each value for x and multiply by the p of x. But you might notice here that if you multiply these out, you're actually going to get 1/2 every time. 1 times 1/2 is 1/2. 2 times 1/4 is 2/4, or 1/2. 4 times 1/8 is 4/8, or 1/2. So all of them are going to be 1/2. So I'm writing this down here. The expected value actually ends up being 1/2 added an infinite number of times, which ends up being infinity. Which kind of suggests that you should be able to pay like any amount of money to play this game. But which seems kind of weird because, most of the time you're only going to win a few dollars. But, based on expected value takes into consideration the extreme cases, right? Like the chance that you flip, 700 tails and then you get the first heads, right? You make, trillions or quadrillions or a Googleplex amount of money, right? But the chances of that happening are so incredibly small that, for most of us, we're going to say that that's probably out of reach. That's probably not going to happen for most of us. So maybe the expected value is not really the best metric to make our, wagering decision based on this game. But nevertheless, we're gonna simulate this game here in Google Sheets, and we're gonna simulate this like 100 games at a time and see how many, like the highest number of heads we can get here. Okay, just a disclaimer here, not really disclaimer, but when I did this, the highest I could get was 17. I got at one point 17 flips to get my first heads, which I don't remember how much money I made, but I didn't actually make any money. I'm not actually gambling here, but you'll see the point as we kind of make it through here. We're going to be simulating this game, and I think this is a really cool simulation, and I think you will enjoy it. So let's get into this. So the way I'm going to do this is I'm going to have a right in here. I'm going to put a simulation number, kind of slash flip number, and what that's going to represent is my rows here are going to represent the flip number, and the columns are going to represent the flip number, and the rows are going to represent the simulation number. I think I spelled that wrong. Simulation number, right? And I'm going to do this for up to a possible value of 20 flips. Okay, so I'm gonna type in. Actually, before I do this, I'm gonna decrease the size of some of these cells here. So I'm gonna highlight all the way through U, and I'm gonna just kind of decrease this here. So that those are a little bit smaller, because these cells are all just going to contain either numbers or H's or T's, and I want to be able to fit them all on the screen at one time. So I'm gonna shrink those. So the way I shrunk those is if you highlight them all, and then you can kind of increase or decrease them all at the same time. Okay, so now that once I've got that, I could have I'm going to do this for 20 possible flips. So I'm going to type in 1 and 2 into B1 and to C1. I'm going to highlight both of those cells, and I'm going to drag that all the way through U1, and I'm going to get the numbers from 1 to 20. So that basically gives us the opportunity to flip up to 20 flips. The chance that we have to flip more than 20 times is like 1 out of 500,000 chance. It could happen, but it's pretty unlikely. So most likely this is going to work for the vast majority of us with 20, but if you really wanted to, you could go more than 20. You could do it, 25 or something to really cover all your bases, but I'm only going to do this for a possible 20 flips, right? And I'm also going to do 100 simulations at a time. So I'm going to type in 1 and 2. I'm going to highlight those, and I'm going to drag this down through cell 101, I think is what I need. Yeah, cell 101 or row 101 to get the numbers from 1 through 100. Now, I want to actually do the simulation. So this would be like playing the game the first time. This first row is like you're playing the game the first time. The next row would be, oh, you're playing it a second time, a third time, a fourth time, right? And so each time you play the game, you're gonna flip a coin. And this is going to be the first flip of the coin. So we want to generate the outcome of one flip of the coin. And on one flip of the coin, we could either get a heads or a tails. So basically, we want this cell to either display an H or a T, depending on basically a random number that has been generated. So we're gonna use the random between function, and I'm gonna do random between 0 and 1, and that's gonna generate a random number between 0 and 1. So you can see if I press enter, it's gonna give me a random number here. It gave me a 0. So maybe we would say the zeros are gonna represent the tails, and maybe the ones are gonna represent the heads, right? Now, instead of letting this give me a 0 or a 1, I want this to give me a T or an H. So the way I can do this is I can use an if function at the beginning here. And I can say, well, if my random between function returns a 1, so I can say equal to 1, do a comma. Well, if that is true, if my random between function gives me a 1, then I want this cell to give me an H. So I'm going to do quotes H. Since H is a text there, I got to use the quotes. And then comma, well, if I did not get a 1, then I must have gotten a 0. And if I get a 0, I want this to be a T. And so I can go ahead and close that. And now it's going to give me a random value, either an H or a T. And you can see if I just modify the cells here, every time that I modify a cell, it's going to recalculate that, right? OK, now the next part is a little bit tricky here. So now the first flip is no problem. The first flip is either going to be heads or tails and no problem. The second flip is a little bit trickier because the second flip, we only want to generate a second flip if the first flip was tails, right? So if the first flip was heads, then the game is over, right? You already flipped heads. The game continues until you flip heads. So if your first flip was a heads, you're done. You don't want to generate another flip. But if your first flip was tails, then you do want to generate another flip here. So I'm gonna create a function in here that's going to account for if this was heads, then it should output nothing, and if this was tails, it should output another coin flip, right? And the way we do this is we're going to have to actually check basically two different conditions here, because I want this to work for any of the cells all the way out here. So like I'm going to eventually have this work for like all the way up to 15. And basically, if the previous cell, the way you got to think about this is for any of these cells, if the previous cell was either blank or a heads, then I don't want to generate a flip, right? So right here, if this is an H, I don't want to generate a flip. But let's say I had like, let's say I changed this and it was like T, 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 and then H, right? And I'm trying to code this one out here, the 12, right? Well, this the previous cell would be a blank, and so I also would not want to generate something in 12, right? So if the previous cell is either an H or a blank, then I don't want to generate a coin flip. So hopefully you kind of see the idea here. For any of the cells in here, I'm going to want to basically say, if the previous cell is either an H or a blank, then I do not want to generate another coin flip. If the previous cell is not an H or a blank, then I do want to generate another coin flip. Okay, I feel like I'm over-explaining this, but let's just get into this so I can show you how this works. So the way we can do this is using an if function with an embedded OR function. Now, if you're not familiar with the OR function is going to allow us to check two conditions within our if function. So usually, if just lets you check one logical expression. But we actually have to check two things. We want to check if the previous value is an H, at which point we don't want any more values, or if it's blank, at which point we would also not want to generate a value. So we're going to use the OR function here. So the first thing we want to check is if this value, the previous value, is equal to a blank. And then I'm going to do a comma. And that's going to basically give me to a second condition, right? So either this value could be a blank, or if this value was equal to a tails. And you could do these in either order. You could have a blank and then tails, or either way. Actually, heads is what I should have here. Heads, right? So if this value is either a blank or a heads, then I don't want to generate anything. So I'm going to do comma here, and the value if true. Well, if that's true, if it's true that the previous value is either heads or a blank, then I want to also output a blank here. Otherwise, I want to output another random number here. So I'm going to do the rand between again. Actually, I need the if rand between, right? Rand between 0 and 1 is equal to 1. It needs to be heads, or if it was false, it would be tails. Basically just the same function that we had written before, right? So let me go through this whole thing and try to explain this all to you right here, because I don't know how well of a job I did as I was going through it. So first we have an if function out here, which says we're going to check the condition of the previous cell to see if the previous cell was either a blank or a heads. If that previous cell was either a blank or a heads, then we're going to output nothing. If it was not a blank or a heads, then we're going to output another flip of the coin. And that flip of the coin is going to be either heads or tails based on the outcome of the random number there. Okay, so let's go ahead and press enter. I'm gonna grab this and I'm gonna drag this all the way through 20. I'm gonna grab all of this here and I'm going to drag this all the way down through row 101 here. And now you should be able to see the game playing out 100 times, right? So the first time the game played out, we got tails and then heads, so it went twice. This person would have won $2. This one went, I guess, 4 flips. So this would have been, the first flip is $1, 2, 4. This person would have won $8, right? And let's see what the highest we got here was on the 5th flip, it looks like. Ooh, we got all the way out on the 8th flip here. What you might want to do here is you may want to freeze your first row. Oops. You may want to freeze your first row here. So I'm going to go to view, freeze one row. You don't really need to freeze the column, although it looks a little bit nicer. So I guess if you want to, you can freeze a column as well. And now we can see those rows or those columns anywhere we go. So this one actually made it to the 8th flip. And it looks like that's as far as we made it, right? And anytime I modify any cell, anytime I modify any cell, I don't want to modify a cell inside there, it's going to regenerate the game, right? All right, so that's all well and good. We got our game to work here. So now we have a couple other things to do here. So let's have our let's basically count the first success as well as the winnings. And here in a second, we're also going to want to calculate the max flips, the max winnings, the average flips, and the average winnings. Okay, so the first success. This is basically counting or figuring out, which trial was it that we had the first heads basically happen, right? And the way that we can do this is we can count the number of tails and add 1. So think about that, right? So like in this one, the first heads happened on the 4th flip, right? So that means there were 3 tails and then a heads. So one way to do this, if we want to figure out which flip we were on, is we can count the number of tails and we can add 1, right? So there are 3 tails here, plus 1 would give us the 4th was the flip of the heads. Or here there were 2 tails and then a head. So if we count the number of tails and we add 1, we will get the flip on which the heads occurred. So we can do that by use of a COUNTIF function. So I'm going to highlight this whole range. And I'm going to count this. The next one here is the criterion. I only want to count it if the output is a tail. And then I'm going to add 1 to that outcome. And you can see here, it's counting the tails. There are 0 tails. And it's adding 1 to that, which gives us, our last trial was on the very first trial, right? Let me go ahead and drag this all the way down to make sure this works here. And I think it should. Yes, it is. So now what this is telling us is which trial did that first heads come on, right? Or that first success, right? So you can see here I have a 5, which tells us, this was the fifth trial was when we flipped that heads. Looks like we got a 7 was the highest we got here, and that is about it. And then we can go ahead and we can calculate our winnings. So the way you can calculate your winnings is if you take 2 and you raise it to 1 lower than your number of success power. Remember that the money just doubled each time, right? So you win $1 on the first trial, 2, and then 4, 6, 8. Or I didn't count that right. 2. It's 1, 2, 4, 8, 16, 32, 64, etc. Right? And basically you're just doubling each time. So that's like 2 to the power of something. It turns out it's 2 to the power of 1 less than your number of successes. So if your success was on your first success was on the 3rd trial, then you would actually make 2 to the 2nd power of money, right? So because you would make $1, $2, $4, which is 2 to the 2nd power. So just take my word for it here. If you're not seeing it, it's always going to be 2 raised to 1 less power of whatever this number is here. So we can do this by taking 2 and raising it to, open parentheses, this number minus 1. And then let's drag that down, or I can just double click that there, and then that is going to give us the correct result. So we can kind of see that here, and we can kind of verify this. This would be 1, 2, 4, 8, 16, 32, and the winnings are giving us 32. 16, 1, 2, 4, 8, 16. Did we get anything higher? We got a 64. Looks like 64 was the highest we got on any of these, right? All right, we're almost done here, so let's calculate the maximum number of flips. So we're going to use the max function to do this. So basically, out of our simulation of 100, what was the maximum number of flips that we needed to get our first success? So I'm going to highlight all of those, Control-Shift down arrow to highlight all of those, or you can just drag through it. So it looks like in this simulation, the highest was 8. Where was that? Right here, I think was that. And then anytime that I update the cells, these are gonna change as well. And then let's do the max winnings. So the max winnings is going to be the max of this one. So it looks like I got 8 again. So the average flips, we'll do the average of the first success. So on average, on this iteration, it took between 1 and 2 flips to get the first success on average, and then the average winnings, we can find that as well. Did something wrong there. Let's try that one more time. Average of the winnings. There we go. So I took the average of the winnings, and I got 3.7 in this case. Now let's go ahead and insert a, so I'm on Y7 there. I'm going to insert a checkbox, and then whenever I press that checkbox, it's going to basically redo the simulation. Oh, I got 12 there, so that's a little bit higher than what I've been getting before. Let me decrease the decimals on a couple of these. Oh, and I lost that. So let's see if I can get a number at least like 12 again. I'm going to see if I can get something at least 12. So I'm watching the max flips here. I want to get a number at least 12. Come on, we can do it. I got 17 here when I was doing this for a couple minutes before I did this, and I was able to get as high as a 17. So if you can get higher, if you can get 20, then pause your sheet, send it to me, because you've just witnessed something that is very rare. I want to get something at least 12. Come on, I got 11 a couple times here. We can do this. I am not getting very lucky with these. I'm getting 11s a few times. I'm afraid of that. I'm going to just click past it when it happens. 10, 10, 13. Okay, there we go. 13. That's the highest I think I got here today. So where is that one? Here you go. So I flipped 12 tails before my first heads. So this would be winning $4,096, right? If this would have been your trial, right? So kind of interesting, kind of fun there. So if you want to, you just, press through these as many times. Ooh, 15, look at that. Oh my goodness. So this one would have won $16,384, right? So you can, it's kind of fun. You can just click through this. So if you go through the practice problem, you're going to do a similar problem with the dice game here. And you're also going to create a hypergeometric distribution similar to binomial. So I highly encourage you to check those out. But anyways, this is the St. Petersburg paradox, and hopefully you enjoyed this and found this to be interesting. But I think that's all I have for you in this video.